Hi guys, welcome to Momentum with Vedantu. Thank you so much for coming here. Today we are going to discuss the questions from JEE 2020 papers. Okay, so I have a few questions with me. We are going to solve these questions in this video. Okay, we are going to solve this video we are going to solve those questions in this video, and you are going to do that with me. Okay, so all right, let's just get right into it. Let's just get right into it, guys. Let's look at the first question. What is the first question? I have a capacitor with a capacity of 5 microfarads and it is charged to 220 volts. Now this charged 5 microfarad capacitors is connected to another uncharged capacitor of capacity 2.5 microfarads. You have to find the heat lost in the process. You have to find the heat lost in the process. Now, this might look like a very hard question, guys, but it's not. It's not. You can solve it very, very easily. Okay, it's a very standard question. You can even call this an NCRT question because this type of questions do come in the NCRT board exams. Okay, these type of questions do come in the NCRT board exams. How do we solve this? How do we solve this? So, first of all, guys, let's make the diagrams. Okay, let's make the diagrams depicting the initial and the final criteria. Okay, so initially I have two capacitors and both of them, one of them is charged. I have a 5 microfarad and a 2.5 microfarad capacitor. Okay, one of them is charged to a potential difference of 220 volts. The other one is uncharged. Okay, this is the situation, guys. This is the situation before. This is the situation before. Okay, what is the situation after? What is the situation after? Afterwards, I have connected both the capacitors together. I have connected both the capacitors together. Okay, and now charge redistribution, guys. Charge redistribution will take place. Okay, so now this will be still 5 microfarads. This will still be 5 microfarads. I hope everybody can see that. This will still be 2.5 microfarads. But now the charge redistribution will take place. So both the capacitors will be charged to a certain potential. Now let's say the potential difference of this 5 microfarads is Vf, then the potential difference of the 2.5 microfarads will also be Vf. Will have Both the capacitors will have the same potential difference. Both the capacitors will have the same potential difference. This is the situation, guys, after the switch is closed. Okay, now here, guys, you have to understand that let's say initially the charge on this plate was equal to Qi. Let's say that initially the charge on this plate was equal to Qi, and finally charge on this plate was Q1 and charge on this plate was Q2. Then guys, what we can say is Qi will be equal to Q1 plus Q2. What we can say is Qi will be equal to Q1 plus Q2. Now you have to understand that since this is a capacitor, we will always use the formula Q is equal to C into V. Q is equal to C into V, and using that we can find the charge on all three capacitors. Okay, so let's try to do that, guys. Let's try to do that. I can write Qi as equal to 5 into 220 microfarads, not microfarads, microcoulombs. Q1 can be written as 5 into Vf microcoulombs. Okay, and Q2 can be written as 2.5 into Vf microcoulombs. Okay, I hope everybody understood. I hope everybody is following. Okay, so far using the equation Qi is equal to Q1 plus Q2, what I can say is that 5 into 220 will be equal to 5 plus 2.5 into Vf. Okay, guys, this very easily gives me the value of Vf. This very easily gives me the value of Vf as 220 into 5 divided by 7.5. This very easily gives me the value of Vf as 220 into 5 divided by 7.5. I hope everybody understood. I really hope everybody understood. Okay, now that we know that it's very easy to calculate, now that we know that it's very easy to calculate the heat loss. Now for that, I need to calculate the initial energy stored in the capacitors. Okay, what will be the initial energy stored in the capacitor? Only one capacitor was charged, so initial energy stored will be half into 5 into 220 square. This energy will be in microjoules because my capacitance is in microcoulombs. Okay, and similarly, guys, I can calculate the final energy stored. Okay, the final energy stored. What will be the final energy stored, guys? The final energy stored will be nothing. Final energy stored will be nothing but half into 5 into Vf square plus half into 2.5, half into 2.5 into Vf square. That if you write, it will be half into 7.5 into Vf square. Okay, let's calculate this final energy a little bit more precisely. So the final potential energy will be nothing but half into 7.5 into 220 square into 5 square divided by 7.5 square. Okay, guys. Now, if you rearrange it a little bit, this will just become half into 5 into 220 square into 5 divided by 7.5. Okay, 5 divided by 7.5 microjoules. Now, as you can see, this energy is already lower. This energy is already lower than the initial energy. So, I can calculate easily the heat lost. Okay, the heat lost, guys, will be equal to how much the energy reduces, and the difference will be equal to this difference will be equal to the amount of heat generated. So that will just be nothing but half into 5 into 220 square minus half into 5 into 220 square times 5 divided by 7.5. Okay, I hope everybody can see whatever I'm writing. Okay, if you try to calculate this one more time, this will give you heat lost. Okay, this will give you heat lost is equal to half into 5 into 220 square into 2.5 divided by 7.5. Okay, now guys, if you try to do this calculation, you have to understand this, and this will cancel out. 1 and 3 will remain. Okay, so this is nothing but 5 into 220 into 220 divided by 5 into 220. One second, huh? One second. 5 into 220 into 220 divided by 2 into 3. This will just become 110 here, and if you calculate this, this will be 5 into 110 into 220. That will be 121,00121,000 divided by 3 microjoules. If you convert this into joules, this will be 121 by 3 into 10 power minus 3 joules. Okay, so guys, the answer to this question will be equal to how much? The answer to this question will be 121 divided by 3 into 10 power minus 3 joules. I hope everybody understood it. Really hope everybody understood it. Was I going too fast? Was I going too fast? I hope not. I hope not. Think I think there was a little bit of issue with this. Let me try to reopen this one more time. Let me try to reopen this one more time. 1 second. Okay. Yes, I hope it's back again. Yes, it's back up again. Okay, there was a little bit of problem. There's some issue with my computer. I don't understand. But anyways, okay. Now, next is what? The stopping potential. The next question is also very interesting one. The stopping potential of an emitted photoelectron is V when the monochromatic wavelength A lambda is incident on the metal surface. Now, if the wavelength becomes 3 lambda, then the potential becomes V by 4. Then you have to find the threshold wavelength k lambda. Okay, you have to start with the assumption that the lambda naught is equal to k times lambda, and you have to find the value of k. Okay, this is an integer type question, guys. It's not a very hard question. Once again, it's very simple question. These type of questions once again come in boards as well, but you have to be aware of it. Okay, these are all standard questions, guys. So first of all, what we can do is we can say the Einstein's photoelectric equation. I can say EV stopping potential is equal to hc by lambda minus hc by lambda naught. Okay, EVS is equal to HC by lambda minus HC by lambda naught. If I substitute the value of lambda naught here, I can write EVS is equal to HC by lambda minus HC by K lambda. Okay, now you just have to see that we have here two cases. In case one, the wavelength is lambda and the stopping potential is V. In the second case, I have wavelength 3 lambda and stopping potential V by 4. Okay, so for both the cases, I will write down the equation. In case one, I will write E into V is HC by lambda minus HC by K lambda. Okay, and in the second case, guys, I will write E into V by 4 is equal to HC by 3 lambda minus HC by K lambda. Alright, I hope everybody can understand this. I hope everybody can understand this. Now, guys, from this, if you had to calculate the value of K, it was very easy. What you have to do is you just got to divide the equations, my friends. You just got to divide the equations. Okay, what you can write is, or you know what, don't even divide the equations. What you can write is that. mm from, you know what, I will write the equation 2 once again. Okay, so it's just so that you understand. From the second equation, I can write EV is equal to 4HC by 3 lambda minus 4HC by K lambda. Okay, very simple, very simple. I hope everybody understood. Now let's say this is equation 2 here. Now if you compare, guys, if you compare equation 1 and equation 2, both of them have the same LHS. Both of them have the same LHS, so we can equate the RHS of both of them. So I can just write HC by lambda minus HC by K lambda is equal to 4HC by 3 lambda minus 4HC by K lambda. Now, if you see, guys, here HC gets cancelled out. You can also see lambda gets cancelled out. Okay, what remains is something which is very easy to solve. You can write 1 minus 1 by K is equal to 4 by 3 minus 4 by K. Okay, so let's just do a little bit of rearrangement. You can write 4 by 3 minus 1 is equal to 4 by k minus 1 by k, or I get 3 by k is equal to 3 by k is equal to what? 3 by k, 4 by k minus 1 by k is equal to 4 by 3 minus 4 by k, correct, which gives me 3 by k is equal to 1 by 3. Okay, 3 by k is equal to 1 by 3, or k is equal to 9. Okay, k is equal to 9. So this question also you can solve very easily. K will be equal to 9. All right, I hope everybody understood. I really hope everybody understood. Okay, guys, let's do the next question. Let's do the next question. What is the next question? I have a hypothetical spherical galaxy of mass density rho is equal to k by r. Now, if a planet is rotating at a distance r naught from the center of the galaxy, find the relation between the time period and the radius r. Now, guys, this is one of those few questions which is not going to be very easy. This question requires a little bit of conceptual knowledge. You will need to integrate here, and a lot of steps to be taken before which we will reach the solution. Okay, so let's just try to make the galaxy first. Okay, let's just try to make the galaxy first. How will you make the galaxy? Let me try to make. Let's say this is the galaxy, guys. Okay, let's say this is the galaxy. Okay, and what I will say is, let's say that this is the center of the galaxy. This is the center of the galaxy. And you are at a distance r naught from the center of the galaxy. You are at a distance r naught from the center of the galaxy. You have a satellite of mass m. Okay, and it is going on a circular path with certain orbital velocity v0. It will go like this. Okay, it will go like this. Now, guys, what you need to understand here is that we have a formula for orbital velocity. Do you guys know what is the formula for orbital velocity? The formula for orbital velocity is under root gm by r naught. The formula for orbital velocity is under root gm by r naught. It's very simple formula. But in order to calculate this formula, in order to calculate this orbital velocity, you need to calculate the value of mass. Okay, now what will be this mass? The mass contained within this spherical region. It will be the mass contained within this spherical region. Now, if you can calculate this mass, you will be able to calculate what? You will be able to calculate the orbital velocity, and then you can calculate time period very, very easily. Okay, so in order to calculate mass, you will need to use the density equation which is given to us. Okay, what is given to us is that if, let's say, this is the galaxy. Okay, let me make the galaxy one more time. Okay, I'm very good at drawing galaxies, not really. Okay, let's say this is the galaxy and this is the center of the galaxy. I want to calculate the mass within a radius of r naught. So in order to do that, guys, what I will do is I will go at a distance r, and I will take a thin spherical shell of a radius dr. I will take a thin spherical shell of a radius dr. Okay, so I will take something like this. This is what I will take. Okay, so now guys, if I take look at this spherical region, if I look at this spherical region, what will happen is that this spherical region will have certain mass. Let's say the mass of the spherical region is dm. Now, what I can write is that the mass density will be equal to dm divided by dv. Here dV is the volume of this small spherical shell, and that will be equal to how much the volume of the small spherical shell is. Imagine this is an area. So what will be the area of the surface? It will be 4 pi r square, and that area has a thickness of dr. Okay, so you can write the volume as area into thickness, or in this case, 4 pi r square into dr. Alright guys, I hope everybody understood. I really hope everybody understood. So from this, you can get m is equal to rho into dv, which is equal to k by r, because if you see, rho is given to us as k by r, okay, into rho is given to us as k by r into, अरे 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 चीजें मेरे हाथ से नहीं निकल लीजिए, k by r into 4 pi r square dr, into 4 pi r square dr. Okay, now if you can see, one r will get cancelled out with one r, and I will get overall dm is equal to 4 pi k into r into dr. Now, this is not a very hard equation, guys. To understand, this is not a very hard equation to integrate. I just have dm is equal to 4 pi k r dr. If I want to find out the entire mass, I just have to integrate this. And when I integrate this, I have to integrate from 0 to r naught. Okay guys, which gives me very simply the mass is equal to 4 pi k r naught square by 2, or I can just write 2 pi k r naught square. Okay, this gives me, guys, this very simply gives me the orbital velocity, which was under root of gm by r naught, as under root g into 2 pi k r naught square divided by r naught. Okay, or the orbital velocity will be equal to under root 2 pi kg r naught. Okay, under root 2 pi kg or not. I hope you can see this, guys. I hope you can see this. It's very, very simple. Nothing terrible happening here. Okay, now you're not interested in calculating the orbital velocity, guys. You are interested in calculating the time period. You have to understand the time period is going to be nothing. The time period is going to be nothing but 2 pi r naught, that is the distance traveled in one full cycle, divided by the orbital velocity. Okay, so that will be just 2 pi r naught divided by under root 2 pi kg r naught. Okay, if you see this, this will just become under root 2 pi r naught by kg. This will just become under root 2 pi r naught by kg. Do you see how that happened? Do you see how that happened? Yes, I think you guys can see that. Okay, so from that I will get the answer as option C. Easy peasy Japanesey. Okay, so next next is I have a charge q distributed on two concentric spheres of radius r and r respectively. If the charge, not charger density, if the charge density of both the spheres is same, then you have to find the electric potential at the center. Okay, you have to find the electric potential at the center. Now this might look at like a very hard question, guys, but once again it's just a little bit of faltu data that you have to distribute the charges in this and that, and it's just it feels hard, but it's just a very painful question. Yeah, it's just a very painful question. I don't like this question just because it's painful. Okay, nothing else. It's a nice question. It's a J standard case also. It's a very good question. Okay, but I just don't like this because it's a painful question. So let's just make this situation. Okay, let's just draw this situation here. So I have two concentric spheres. Okay, I have two concentric spheres. Yeah, they are concentric. Here. Okay, and both of them have radiuses r and capital R respectively. Okay, both of them have radiuses r and capital R respectively. You know what, let me just copy this onto a new page. That will be better. Okay, so both of them have अरे आजा यार आजा हाँ. Okay, so both of them have radiuses r and capital R respectively. Okay, so let me just write this. Let's say this radius is equal to r, and this radius is equal to capital R, and charge q is distributed on both of them. Okay, so let's say this has charge x and this has charge q minus x, because the charge q is distributed on both of them. Okay, now what they've said is that this areal charge density is the same for both of them. Okay, or what I can say is x divided by 4 pi r square is equal to q minus x divided by 4 pi r square. Do you see this, guys? Do you see this? If you cancel out 4 pi and 4 pi, guys, you can write x is equal to q r square by r square minus x r square by r square. Okay, substituting this, taking this here, I get x plus x r square by r square is equal to q r square by r square. Okay, or I can write this as x into r square plus r square is equal to q r square, or x is equal to q times r square upon r square plus r square. Okay, this is the charge density, guys. I hope everybody can see this. I hope everybody can see this. Now that we know the charge density, guys, okay, what we are going to do is we are going to find out. Now that we know the charge density, guys, what we are going to do is we are going to find out the potential. Okay, but first let me make everything the same as before. Here I had charges, radius is r and capital R, and charges x and q minus x. Now guys, if you try to find the potential at center, what will be the potential at the center? Potential at center will be potential due to the first sphere plus potential due to the second sphere. Now potential due to the inner sphere will be k into x divided by small r, plus potential due to the second sphere will be k into q minus x divided by capital R. Okay, so let's try to substitute the value of x here. This will be k by r into q r square upon r square plus r square. Okay, and by the way, let's try to calculate the value of q minus x is separately here. If you try to calculate the value of q minus x, that will be q minus q r square upon r square plus r square. Okay, if you try to calculate this, guys, this will just be equal to q capital R square upon r square plus r square. Okay guys, so let's just substitute that here. So that will be plus k by r into q capital R square upon r square plus r square. If I am not wrong, if I am not wrong, am I wrong anywhere? Am I wrong anywhere? No, how can I be wrong? I am always correct. I am always correct. Okay, so now if you see here guys, if you see here, some things will get cancelled out. This r will get cancelled out with this r square, this r will get cancelled out with this r square. I can actually take this kq common, and you get vc is equal to kq into r plus r upon r square plus r square. Okay, super duper easy guys. That will just be option B. That will just be option B. I hope everybody understood, guys. I really hope everybody understood. Okay, now you have a hydrogen atom that jumps from n plus 1th state to nth state. Okay, and you have to find the frequency of emitted photon. Okay, and what is it directly proportional to? So now guys, this is a formula which requires a little bit of approximation. Let's try to do that approximation. Okay, so hydrogen atom jumps from n plus 1th state to nth state. Okay, it jumps from n plus 1th state to nth state. So if you want to calculate the frequency, you can write the frequency h into f. Okay, you know what, you can write 1 by lambda as equal to 1 by lambda is equal to r into 1 by n square minus 1 by n plus 1 the whole square. Okay, and from this, if you just want to write frequency, you can write this as CRC into 1 by n square. Okay, minus 1 by n plus 1 the whole square. If you're wondering how I wrote that, you have to remember that frequency is nothing but c by lambda or c into 1 by lambda. Okay, from this I get frequency equals to this. Now here is where you just need to approximate a little bit. F is equal to R into C into n plus 1 the whole square minus n square upon n square into n plus 1 the whole square. Now, if you do this approximation, guys, you will get F is equal to R into C into this will be 2n plus 1 divided by n square into n plus 1 the whole square. Okay, now if I have n much greater than 1, if I have n much greater than 1, then f will approximately become rc into 2n divided by n raised to the power 4. Okay, because in that case n plus 1 can just be approximated to n. So I get nothing but F is approximately equal to 2RC divided by n cube. Now if you see here, F is proportional to 1 by n cubes. So the correct answer will be option D, 1 divided by n cube. I hope everybody understood, guys. I hope everybody understood here. Okay. Next, a particle is projected with a velocity v for point O. Okay, from point O, not for point O, from point O. Okay, and the particle makes 10 revolutions before coming out of the magnetic field. Okay, so there is a magnetic field in this direction, guys, and it's between 0 and F. So when the particle goes, the particle makes approximately 10 revolutions, okay, before coming out of here. Okay, so you have to find the value of the length L. You have to find the value of the length L. Now, you have to remember, guys, you have to remember that in this case, this particle will have two different velocities. It will have v cos 60 in this direction, and it will have v sin 60 in this direction. Okay, now its velocity in x direction, which is v cos 60, will remain unchanged throughout the motion. This will remain unchanged. Okay, not unchanged, unchanged throughout the motion. Okay, so now in this case, if I ask you, let's call this point A. Okay, if I ask you how much time will it take to travel distance x along? Okay, so time taken by particle to come out of magnetic field, to come out of magnetic field, to come out of magnetic field. So everybody knows that the time taken is nothing but the time taken, let's call it delta t1, is nothing but distance traveled divided by the velocity. Distance traveled divided by the velocity, which will just be 2L divided by V. Okay, also at the same time, guys, you have to remember when a particle is undergoing particle is undergoing helical motion, the time period here is given by time period of what? Time period of one revolution. Okay, that is given by 2 pi m divided by q into b. 2 pi m divided by q into b. Now, in this case, what you have to understand is, that that the time period delta t1 is equal to 10 times t. Time period delta t1, the time that the particle takes to come out of magnetic field, should be equal to 10 times the time period of one revolution. Okay, because it makes 10 revolutions before coming out. So I will just substitute the values. I will write 2L divided by V is equal to 10 into 2 pi m divided by q into b. 10 into 2 pi m divided by q into b. Okay, from this, guys, if you try to calculate L, first of all, this 2 and 2 gets cancelled out. This 2 and 2 gets cancelled out. Okay, if you try to calculate the value of L, L will be equal to 10 pi mv by qb. You see, it will be 10 pi mv by qb. So that will be nothing but that. I'm guessing there is a 10 here. I'm guessing there's a 10 here. Did I make a mistake, guys? Did I make a mistake? Time period is 2 pi m by qb. Yes, yes, yes. Okay. And in the second case, did I make a mistake here? No, I don't think so. No, I don't think so, sir. I think it's supposed to be 10 pi mv by qb. Okay, but I don't know if I have made a mistake, guys. If you can notice my mistakes, please write it in the comment section below. Okay, I am a person who makes a lot of mistakes. So comment if I made a mistake. Comment if I made a mistake. Okay, there is a chance that I made a mistake here. Okay, so please comment. Be nice about it. Okay, be nice about it. I think I made a mistake, but don't know. Who knows? Okay, now. Next is pressure inside two soap bubbles is 0.01 atmosphere and 1.01 atmosphere and 1.02 atmospheres. You have to find the ratio of their volumes. So guys, you have to understand here, this is very, very simple. Let's say I have two soap bubbles, soap bubble 1 and soap bubble 2. The outside pressure, guys, is always going to be 1 atm and 1 atm because these bubbles are in air. Okay, and the inside pressure will be equal to what? The inside pressure will be equal to the outside pressure, which is 1 atm plus 4T by R. The outside pressure plus 4T by R. Now, looking at the data, guys, looking at the data, it's a super simple to see. It's a super simple to see that let's say the first one had radius R1 and the second one had radius R2. It's a super simple to see that 4T by R1 will be 0.01 atm. Okay, and 4T divided by R2 is equal to 0.02 atm. Alright guys, now from this, if I divide these two equations, 1 and 2, okay, I will do equation 2 divided by equation 1. Okay, if I do equation 2 divided by equation 1, what I get is 4T by R2 into R1 divided by 4T is equal to 0.02 divided by 0.01, which gives me R1 by R2 is equal to 2. Now, if I have to calculate the ratio of volumes V1 by V2, that will be nothing but the ratio of cube of the radius. Okay, that will be nothing but 8. So the correct answer is the ratio of their volumes will be 8 is to 1. The ratio of their volumes will be 8 is to 1. I hope it is clear to each and every one of you. If you did not understand, please comment in the comment section. Okay, and also if you did understood, then please like this video and subscribe to our channel. Okay, next, if you have to find the lambda max minus lambda min for Lyman series, it will be 340 angstroms. Okay, you have to find the same for partition series. Now guys, in such questions, whenever such data is given, you have to use that data somehow. Okay, so if I talk about Lyman series, okay, if I talk about Lyman series, okay, in this case the wavelength is given as what? 1 by lambda is equal to r into 1 by 1 square minus 1 by n square. Okay, now if I ask you how much will be the lambda maximum here, so I can write 1 by lambda maximum will be nothing but r into 1 by 1 square minus 1 by 2 square. Okay, because in this case the energy gap will be minimum and therefore the wavelength will be maximum. So I can write 1 by lambda max is nothing but 1 by lambda max is nothing but r into 3 by 4, yeah, 3r by 4, or I get lambda max is equal to 4 by 3r. Okay, I hope everybody understood, guys. I hope everybody understood. Okay, similarly for Lyman series, if I try to calculate lambda minimum, then I can write 1 by lambda minimum will be equal to r into 1 by 1 square minus 1 by infinity square, because in this case the energy difference is maximum and therefore the wavelength will be minimum. So lambda minimum here, guys, I will just get as 1 by r. Now, if I calculate lambda maximum minus lambda minimum, okay, that will be nothing but 4 by 3r minus 1 by r. That is given as a 340 angstrom. Okay, so if you see this, this will be nothing but, this will be nothing but 1 by 3r. Okay, that will be nothing but 1 by 3r. That is equal to 340 angstrom. Okay, let's just remember this data for further use. Okay, let's just remember this data for further use. Okay, now if I talk about Paschen series, guys, what exactly is Paschen series? Paschen series is basically when you have a jump happening to the third orbit, okay, or Lyman downward Paschen. Okay, so it will be equal to nothing but r into 1 divided by r into 1 divided by 3 square minus 1 divided by n square. Now in this case, once again, if I try to find out the lambda maximum, that will be nothing but r into 1 by 3 square minus 1 by 4 square. Okay, that will be nothing but 7r divided by the 9 is 16 minus 9 is 7, and this will be 9 into 16 is 144. Okay, 1 by lambda max is 144. So lambda max will be equal to what? Lambda max will be equal to 144 divided by 7r. Okay, 144 divided by 7r. Now, similarly, if I try to find out lambda minimum, I can write 1 by lambda minimum will be nothing but r into 1 by 3 square minus 1 by infinity square. That will just be r by 9, or lambda minimum is equal to 9 by. Okay, so in this case also I can calculate, lambda maximum minus lambda minimum. Okay, that will be equal to 144 by 7r minus 9 by r. Okay, let's take out 9 by r common, guys. Let's take out 9 by r common. Okay, this is 144. So this will be 16 by 7r minus 1 by r. Now, if you do this, this will be equal to not 16 by 7 r by 1 by r, 16 by 7 minus 1. Okay, that will be nothing but 9 into 9 divided by 7r. Okay, 9 into 9 divided by 7r, because 16 by 7 minus 1 is 9 by 7, correct? Okay, so I know the value of 1 by 3r. 1 by 3r is 340 angstrom. Okay, so I can write this as 9 into 9. Okay, you know what, I will just go back to this and can just write 1 by r is equal to 340 into 3. Now you guys know what is 340 into 3? 340 into 2 is 680. You know what, 330 into, oh god, 340 into 3. You know what, my maths is supposed to be the strongest. Okay, that will be 1020. So 1 by r will be 1020 angstroms. Okay, so let's just substitute that here, guys. This becomes very, very simple. So let's just substitute that here. So that will be 81 by 7 into 1020. Okay, 81 by 7 into 1020. Now, is 102 divided by 7? 102 divided by 7? No, it is not. Okay, it is not. So let's just do the multiplication. This will be 11,802 angstroms. Okay, this will be 11,802 angstroms. That is given as option 1. That is given as option 1. I hope everybody understood. I really hope everybody understood. Okay, next, guys, this is the easiest question. This is a very formula based question. If you just remember the formula, you will be able to calculate this answer. Okay, now you have to remember that the internal energy of the molecule is nothing but it's either NCVT or it is F by 2 into N into R into T. Here CV is nothing but F by 2 into R. Here F is degree of freedom. It is degree of freedom. Okay, now for triatomic molecules, guys, F is going to be nothing but, if it's a triatomic nonlinear molecule, F is nothing but 6. Okay, so U will be nothing but 6 by 2 into 1 into R into T, which will be nothing but 3RT, which is option 1, This I didn't even need to go to the second page. This is just it. Okay, this is just it. Now, guys, before I go to the next question, let's talk for a minute about Vedantu's platform. Okay, let's talk for a minute about Vedantu's platform. Guys, if you are preparing for JEE on NEET 2020 or JEE on NEET 2021 or 2022, or basically if you are in class 11th or 12th, okay, then the Vedantu's platform is just for you. You should go and take the pro subscription on the Vedantu platform. Okay, what exactly happens if you take the pro subscription, guys? You take access to all live courses. Okay, no matter what live courses are there, you get access to it. And what happens is you get to choose your own teacher. If you do not like your teacher, you can change your teacher. Okay, also at the same time you get access to all micro courses. Okay, now what exactly are micro courses, guys? So let's say you studied friction once and you realize that, I did not understand friction, what to do. So what you can do is you can subscribe to these micro courses, okay, for free. If you have pro subscription, you get the micro courses for free. And what happens is that you get to sit through live lectures once again and understand it better. Okay, also at the same time, guys, you would get to choose your language. If you're comfortable in Hindi, you get to study in Hindi. If you're comfortable in English, you get to study in English. Okay, also at the same time, you get to study from India's best teachers that Vedantu has handpicked himself. Okay, our AP sir has handpicked all the teachers himself. Okay, and all of them have 5+ years of experience. Okay, so now what do you do? What do you have to do if you want to if you want to get a pro subscription? Nothing, guys. You have to go to vdnt.in/ytpro. Okay, you have to go to vdnt.in/ytpro, and when you go there, do remember to use my coupon code. My coupon code is AAPPRO. Okay, it is AAPPRO. It stands for row. Okay, I don't know what it stands for. Okay, it stands for Aam Aadmi Party Pay Rava Omelette. Okay, something like, I don't know what it stands for. Okay, but you use this coupon code, and what happens is you get 50, you get additional 15% discount. Okay, I did not mean to make any jokes on Aam Aadmi Party. Okay, I love them. I love you guys. Okay, all right. Anyway, anyways. So let's do the last question for the day. Okay, what is the last question for the day? I have a mass. I have a mass. Okay, I have a mass which is moving in SHF. Okay, with amplitude A and frequency F in a spring mass system. Suddenly, half of the mass comes to rest just at the moment when it crosses the mean position. Then the new amplitude becomes lambda A. And the new amplitude becomes lambda A. You have to find the value of lambda. You have to find the value of lambda. Now, guys, this is not the easiest question. There is a trick here, and it's very easy to get confused. So let's, you know what we'll do? You know what we'll do? We will try to, um, we will try to properly make the diagrams of before and after. We will try to make the diagrams of before and after. Okay, so let's draw the diagram of before. Okay, let's draw the diagram of before. Okay, I'm going to assume that it's a spring block system. It's not given that it's a spring block system, but let's just assume it's a spring block system. Okay, so let's say I have a spring block system with a spring constant K. Okay, and I have a block, two blocks joined together. Okay, both of them have mass m by 2 and m by 2. Why am I making both of them joined together with mass m by 2 and m by 2? Because half the system is going to half the system is going to what half the system is going to stop, suddenly stop. Okay, half the mass is going to suddenly stop after. Now in general, what is happening is that before this system had an amplitude A. Okay, so from the mean position the system was going up to an extreme position A, and let's say at the mean position it had velocity V0. So do you know what is the relation between the velocity V0 and amplitude A? Yes, I know. The velocity V0 is equal to A into omega, or I can write the velocity V0 as A under root K by M. Okay, A under root K by M. Right now you have to understand, guys, that both the masses m by 2 and m by 2 are linked together. Okay, and they are moving together. Now what happens is suddenly half the mass stops in between. Suddenly half the mass stops in between exactly at the mean position. Okay, so now if suddenly half the mass stops exactly at mean position, what is going to happen is that the spring constant is going to remain the same. The top mass is still going to move with some velocity, let's say v dash, and the bottom mass is going to come to rest. Okay, both of the masses are m by 2 and m by 2. Okay, and now in this case there's just the top mass is oscillating. Let's say it oscillates with a different amplitude A dash. Let's say it oscillates with a different amplitude A dash. Okay, now first of all, if I try to calculate V dash, what can I use? I can use law of conservation of momentum to calculate V dash. Okay, what I can write is that the initial mass into the initial velocity V naught is equal to the final mass into the final velocity. The other mass plus the other mass into the velocity of the other mass. Okay, which gives me V dash is just equal to 2V naught. V dash is just equal to 2V naught. I hope everybody understands here, guys. I really hope everybody understands. Okay, now also at the same time, if I have gotten this, I also can write the relation between V dash and A dash. V dash can just be written as A dash into omega dash. Here you have to remember that since the mass of the system changed, its angular frequency will also change. The new angular frequency will be under root of k divided by m by 2 or under root 2k by. Okay, so substituting everything, guys, I get v dash is equal to a dash into omega dash. Let's substitute all the values. 2 into v naught is equal to a dash into omega dash, or 2 into a into under root k by m is equal to a dash into under root 2k by m. Now, if you see here, k and k will get cancelled out, m and m will get cancelled out, and I will get a dash is equal to 2a divided by root 2, which everybody knows will become just under root 2a. Okay, so that means the correct answer to this question, guys, will be nothing but under root 2a. That will be nothing but under root 2a. This was a very simple question, guys. I hope everybody understood. I really hope everybody understood. If you want me to solve more questions on JEE, please comment in the section below and I will solve more questions maybe tomorrow or day after tomorrow. Okay. If you like this video, please press the like button below. If you are here for the first time, please subscribe to our channel and share this video with your friends if you want to learn with them. Okay, so that is it from me, guys. Have a nice day and I will see you guys tomorrow.